First thing is roots. Roots is the same thing as your x-intercept. Anybody remember from the video? Where do we find that? I heard it. What'd you say? The numerator. Good. So you're going to take this, set that equal to 0. So this comes from the numerator. We're going to always write that as an ordered pair. So if you take the x minus 2, set that equal to 0, you get x equals 2. So we only have one x-intercept. So go ahead and plot that on your graph. Put a point at 2, 0. All right, y-intercept. Now the definition of y-intercept never changes. How do we find the y-intercept? What'd you say?
No, make x 0. Sorry.
Make x 0. Yep. So we know that f of x is the same as y. So we have y equals, then it'll be 0 minus 2 over 0 plus 5. So I'm going to say, I'm making little notes to help you all remember. And of course, we'll go over it again. But the week we come back from fall break, we got a test. So, yeah, that Friday. And it'll be everything that was on the quiz plus graphing. So that's why we couldn't just spend today looking at each other. We're going to at least look at it. And then when we come back, practice more. Okay, so my y-intercept is a decimal. 0, negative 2/5. So I'm going to plot that. That's just going to be a point somewhere between 0 and negative 1. We can't be perfect with that. We just do the best we can. All right, next is our vertical asymptote. Who remembers? Where do we find that? Denominator. So the denominator is your vertical asymptote. So I'm going to take that x plus 5, set that equal to 0, and I get x equals negative 5. That is my vertical asymptote. So if you have a different color, go ahead and draw that in. I'm going to use blue, I guess. So at x equals negative 5, I'm going to draw a vertical asymptote, which is just like a dashed line. I feel like we graphed something. What did we graph earlier that had an asymptote? Oh, it was the piecewise. We had to draw those little fences in. So an asymptote is just a line that the graph will not cross. That's what that is. So if you have a highlighter or a different color, go ahead and draw in your asymptote. Now the horizontal asymptote, that's different. That's tricky, okay? You're going to look at your degree. If your degree, and let me go back. If the degree is the same, so same degree, on the top and bottom, we call that balanced. All we're going to do is divide our leading coefficients. We're just going to use our leading coefficient. And if we look at this example, this one is balanced because they both have a degree of 1. Does everybody see that? So what is the invisible number in front of x for both numerator and denominator? 1. So to find my horizontal asymptote, I'm going to take 1 and divide it by 1. And what is 1 divided by 1? 1. So y equals 1 is my horizontal asymptote. So I'm going to draw that in, make a dashed line. And then we just have our removable discontinuity. So you're only going to have a removable if a factor cancels. And we don't have a quadratic. So we don't have that in this example. So that's NA. So we don't have any quadratic. So you would have to have a quadratic over a quadratic to possibly have one. But this one, we don't have that. So we don't have to worry about that. So we only have 2 points. So from here, we just need to make a T-chart. Now, I recommend, so everyone always says, what numbers do you use? That changes depending upon your graph. I'm noticing that I don't have anything around my vertical asymptote. So I would definitely put in -4 and -6. Let's see what's happening on both sides of the asymptote. So let's start off with that. So on my little T-chart, I'm going to do -4. So that means in my calculator, I'm going to take -4 minus 2 over -4 plus 5. Go ahead and see what you get for -4. So we're just substituting it into our equation. Yes. -6. Anybody else get -6? I'll give everybody else a chance. We're a little faster. So you should get -6 because you have -6 in the top divided by 1, which is -6. So I do have a point at -4, -6. I'm going to go ahead and graph that point. So let's put a point at -4, -6. And now I would probably put in -6 because that's on the other side of my asymptote. Let's see what it's doing on that side. So on the other side, let's put in -6 and let's put in -10. So we can see what's happening right close to the asymptote and at the edge of our graph. Does your graph, I think your graph goes to 10. So go ahead and type in, let's do both of those numbers. Let's do -6 and -10. So all of the weekly Canvas reviews, I don't know if I said this, if I did, I'm just repeating myself. I have reopened them all going back to the first week, and those close, I think at the end of fall break. So I would just get those done. I mean, every week that's 10 points. That is going to add up. At the end of the semester, we're talking about more than 100 points. Those are based off completion, except for the first one. And the first one, I will go back and give you 10 out of 10. But now, after week 2, we figured out how to make it 10 out of 10. So, yeah, just get those done. That's the easy. Those are easy homework points. So let's not leave them on the table. And Canvas, I think I set it up right, but Canvas should automatically at midnight sync it to Skyward. So at midnight, it should like automatically roll over to Skyward. Like after you do it, it should just be there the next day. It did that for you? Oh, good. I did it right. Okay. All right. So -6 we should have. So -8 over -1 is a +8. Who got +8? So let's put a point at -6, +8. Okay. And then let's go ahead and do -10. So -10 minus 2 is -12. -12 divided by -5 is a positive, what, 2 point something? 2.4? We just know it's positive. So let's go ahead and do the best we can to approximate that. It's 2.4? Okay. So then we're going to go to -10. We're going to go up 1, 2, and just a little bit. So from here, you're just going to sketch your graph, keeping in mind that these are asymptotes. So when you graph it, it should not cross either one of these lines. That's why we have what we call, that's how we create an infinite discontinuity. So what you're going to do is you're going to draw a graph. It's going to come down, hit that point, hit that second point, and then all it can do is go straight. It cannot go through y equals 1, and it can't cross x equals -5. So then over here, it's going to come in, hit that point, hit that point, hit that point, and go straight down. So we have an infinite discontinuity at the vertical asymptote. And that's it. Yes, Makira.
How do you get the numbers in the x column?
So like I said earlier, there really isn't a rhyme or reason to it. You just want to fill in places where your graph looks blank. So I noticed that all my points were over here. I didn't have anything over here. So you just kind of want to pick the points you need to get a complete graph. So there really isn't like a formula for it. You just have to look at your graph and see what you need. It's going to be different for every equation. Any questions? And again, we're going to talk about this all again after fall break. I just wanted you all to see it because when we come back, we have like 2 days to finish graphing, 2 days to review, and take a test. So, all right, let's do our second graph of the day. Go ahead and copy this down. I'll give you a moment to get your graph situated. It's the same 5 questions. We're going to answer them over and over again. And we got a new equation and a new graph to put down. So the first thing, whenever you see a quadratic, what do you think your first step is going to be? Factor it. Let's do it down. We got to do that first. We always start with factoring. So I'm going to do that below. So the 2x squared plus x minus 1, I have to make my little box. And then I have my 2x squared here and my -1 here. I need 2 numbers that multiply to give you -2, but add to a +1. So what would be my numbers? +2 and what else? Okay. All right, so let's go ahead and put that in our squares. Take out your GCF. So that should factor down to a 2x minus 1 and an x plus 1. Let me make sure that's right. Is that what you all got? All right, so now let's do our denominator. Fortunately for us, a is 1. We don't have to do a box. We just need to find two numbers that multiply to give you -3 and add to -2. Two numbers that multiply to be -3 and add to give you -2. So that should be -3 and +1. Who got that? So what do you notice? X plus 1 can be removed. This can cancel. So this time we do have a removable discontinuity. So let's figure out where that is. So to figure out where the RD is, we're going to take that x plus 1, set that equal to 0. That's what we canceled. And we should get -1. So I'm going to put, this is an ordered pair. So put -1 right there. And then take the -1, and you're only going to use this. So we don't use what we cancel. This is what we're going to use to answer all of our questions, because we removed the x plus 1. So this is what we're using now to answer all of our questions. I'm going to write it at the top too. So everything is based off y equals 2x minus 1 over x minus 3. All right, so we're not using this. So when you take that -1 and you substitute it in, so that'll be 2 times -1 minus 1 over -1 minus 3. Go ahead and see what you get. So what I just did was I took the -1 that I got and I substituted in the equation that I had left. So who got 3/4 or 0.75? Because this would be -2 minus 1, which is a -3. And this is -4. So this is going to be approximately +3/4. So that's where we have our removable discontinuity. So that looks like a hole in our graph because we talked about that with limits. So at -1/3/4, we have to approximate it. I'm going to put an open circle on my graph. That's the hole that we were talking about. This is a removable discontinuity. Okay, let me give myself a little bit more space. Bring this over. All right, so again, we're using, oops, I don't want to go that far. Oh, it should be above, it's positive, you're right. Thank you. It should be above the, I put it at -3/4, it's +3/4. Let me fix that. Okay, let me do that again. So -1, +3/4. So that's going to be about here. Thank you, Justice. All right, so now we're going to finish out the rest. So y equals 2x minus 1 over x minus 3. So this is what I'm going to use to answer the rest of my questions. All right, roots. Where do we look at for roots? Numerator, go ahead and set that equal to 0. Take that 2x minus 1, set it equal to 0, solve it for x. So roots that comes from the top. So I'm going to take that 2x minus 1, set that equal to 0. We should get x equals 1/2. So I'm going to write that as 1/2, 0. So I'm going to put a point at positive 1/2, so that's about here. All right, y-intercept. How do we find the y-intercept? Yeah, make our x 0. And it's always going to end up being the two constants divided by itself. So you're going to get 1/3 negative 1 over -3, because the 0 is going to cancel out these two terms and just leave you with your two constants. So my y-intercept is going to be at 0, positive 1/3. So let's go ahead and do the best we can. We got a lot happening right here. Wish that makes sense. That's where that is. All right, vertical asymptote. How do we find that? Denominator. So my denominator is x minus 3, because remember, x in your denominator is a red light. Okay, so what this is saying is at x equals 3, the graph is undefined, which is true. So that's why I'm drawing an asymptote at positive 3. Because there is no point that I can put on this dash line. That the graph is undefined at x equals 3. Okay. Now we look at, what do you think this is? Top heavy, bottom heavy, or balanced? Balanced again, because they both have a degree of 1. So we're going to divide these two numbers. That's my leading coefficient. So I'm going to take 2 and divide it by 1. And what do you get? What is 2 divided by 1? 2. So y equals 2 is my horizontal asymptote. So this is what I was saying, like we have to look at what we need. So what are a couple of points? I see 3 points that I would probably use. There isn't a magic formula, but I always do close to my asymptote. So I'm going to start with that. So I'm going to use 2 and 4. So let's go ahead and do that. And then I'm going to probably put something at the end here. And you could put something here, but I just know because of this horizontal asymptote, I know I'm not going to go above 2. So I can actually fill in this side. It's going to come in, hit the removable discontinuity. It's going to kind of skip over that. And then it's going to keep traveling towards the vertical, and it can't go through it. So it just has to go straight down. So we don't need to plug in 3. So let's plug in 4 and 10. Let's see what we have going on at 4 and 10. And again, you're only using what is left. So for the 4, we have 2 times 4 minus 1 over 4 minus 3. Go ahead and see what you get. And then at 10, we have 2 times 10 minus 1 over 10 minus 3. So we are left with, okay, so that's 8 minus 1 is 7. 7 divided by 1. So I think at 4 I got 7. Is that what you all got? 7. So let's go ahead and plot that point. 4 up 7. And then at 10, so that would be 19 divided by 7, which is like 2 point something. Yeah, so it's like 2.7-ish. So I'm gonna just draw that point right above my horizontal asymptote, but right under the 3. And again, when you're connecting it, we have these walls that we can't cross. We can't go through the wall, we can't go through the floor, and that would be your graph. So this has a removable and an infinite discontinuity. All right, last one. We're going to do one that's a special case. Oh, you can go. That's fine. Okay, so this is what we call a special case. So a special case, and the reason why it's special is because of this +1. That +1, if you add a number or subtract a number, in other words, it's not just one fraction, we call that a special case. And when it's a special case, it will affect these two. That's what it's going to affect. So we have to do those a little different. Well, I guess it kind of affects the y-intercept too, but not really. So I'll give you a moment to copy it down. We don't have any quadratics, so this graph will not have a removable. So I'm gonna put NA. Okay. So normally for the roots, we would look at the numerator, but we can't do that this time. And I think I did one in the video yesterday. When it's this way, we have to set y equal to 0 and solve it. So to find my roots, I lost my thing, wow. All right, so to find the roots, I'm gonna set it equal to 0, and I have to just solve it like a regular equation. Oh, there we go. So how would we solve this? Subtract the 1. So that gives us -1 equals x plus 2 over x minus 4. Let's go ahead and cross multiply. So then we have -1 times x minus 4 equals x plus 2. Go ahead and keep solving that. So we should get x equals 1. So that's my root. I'm going to go ahead and write that as an ordered pair. And let's plot that on my graph. Okay. Y-intercept, just like before, y is going to equal 0 plus 2 divided by 0 minus 4 minus 1 plus 1. So that'll give you negative 1/2 plus 1, which is just positive 1/2. So that would be my y-intercept. So I'm going to put that right in between the 0 and the 1. Vertical asymptote still comes from your denominator. So set the x minus 4 equal to 0. What do you get? 4. Go ahead and draw that in. And then we also have our horizontal asymptote. So to find our horizontal asymptote, this is balanced. So it's going to be y equals the 1 over 1, but we still have to add that 1. We can't ignore the 1. The 1 changes a lot. And then when I draw that in, so the only thing I would probably plug in is numbers on the right side of my asymptote. So I always go really close, so I would definitely put in 5, and I would probably put in 10. So I'll give you all a minute to find those two values. Collect up our little sticker trash.
Which equation are we going to substitute in that?
So we're going to substitute it in just the original equation at the top.
Okay.
So we're going to use that, and we should have, so we should have y equals, and then it'll be 0, I'm sorry, not 0, 5, and it'll be plus 2. I don't have my little thing on my pen, so it makes my handwriting messy. Plus 2. And then 5 minus 4. So figure out what that is and then add 1 to it. So you're going to do that for the 5 and for 10. What did you all get for 5 and 10? What did you get, Justice? I can't hear you. 8 and 3? You got 8 and 3? Anybody else get 8 and 3? Keep working if you didn't. Let's see. So this would be 7 over 1 plus 1, yep, which is 8. And for the second one, that would be 12 over 6 plus 1, which is 3, yeah. So when we graph that, we got 5, 8, 10, 3, and we just connected. And this is what we're gonna practice when we come back. We're gonna just graph, and then review, take a test on Friday.